Okay, so we're going to start our lesson today on adding, subtracting, and multiplying polynomials. And you have done this a little bit before in Algebra 1, so it should be somewhat of a review. So to add and subtract polynomials, you're essentially just adding or subtracting your like terms. So this can be done vertically and or horizontally, and your answers must always be expressed in standard form. So the method at which you're doing this is kind of a little variable. Some people kind of do it in different ways. I'll kind of show you a couple different options. But as long as you're getting the correct answer and your answer is in standard form, then that's really the main thing that will matter. Okay, so the biggest mistake I see people make with this kind of stuff is they multiply when they're supposed to be adding or subtracting. And the key that you need to look for is there a sign in between those two parentheses? If there is an addition or subtraction sign in between them, that's when you know you're doing combining like terms versus doing distributing or foiling. So this example here, I'm just going to do it what's called horizontally. And essentially, you're just going to go through, and since you have to have your answer in standard form anyway, I always start out with the highest degree terms that I can combine and work my way down. So in this particular problem, my highest degree terms are this 5x to the third and then this 4x to the third here. So if I were to combine those two, I'm going to get 9x to the third. Then working my way through the problem, the next thing I would look for is any x squares. However, this problem doesn't have any, so then I'm going to move down in descending order. The next thing I would look for is just x's. So I have a negative 2x and a positive 10x. So that would then give me positive 8x. And then, of course, I have my two constants here, 3 minus 7, which will give me negative 4. So that would be the sum of those two polynomials. So now another way of doing this, and the book probably, or problems I give you probably won't be set up this way, but if you were like copying the problem down, sometimes if you copy it and you kind of line up the like terms in columns, then you just have it all set up and ready to go. So this one's just already set up for us. So the two cubic terms are right there, so I can easily just add those up and get 4x cubed. Then you can see my two square terms are lined up together here. So 2 minus 10 would be negative 8x squared. I only had one x term, so I didn't have anything to put underneath it. And then negative 7 plus 8 is just plus 1. Okay, so then number 3, again, there's an addition sign here in between my two parentheses. So in that situation, you want to make sure that you're not multiplying by accident. It's a very common mistake. So again, for this one, I'm going to start out with my largest degree, which I have an x to the fourth and a negative 5x to the fourth. So that's going to give me negative 4x to the fourth. Then I have a cube here, but there's only one of them, so there's nothing for me to combine it with. So I'm just going to go ahead and write it down. Then I would go to my x, but again, there's only one term, that's an x, so I'm just going to write it down. There was no x squares, so I just skipped over that. And then finally have two constants, 8 minus 9, which would be negative 1. So it's pretty simple. You're just combining like terms. Only key things to remember is the answer must be in standard form. And 2, make sure you don't accidentally do multiplication or something else other than addition. Now, as far as the subtraction is concerned, it's pretty much the same thing we just did. The only thing is when you're subtracting here, if you're subtracting, you're not just subtracting the term immediately following the minus sign. Since there's parentheses here, you're subtracting each of these terms. So every single one of those, which essentially is going to, you're going to be distributing the negative to all of those. So this is where sometimes it can be helpful to set it up in that vertical format. So I know that I have this first polynomial here, the 9x to fourth minus 12x cubed plus x squared minus 8. And it's already in standard form for us, so it's kind of nice. So I know I'm going to be subtracting this 3x to the fourth. So I'm just going to put it right underneath my 9 to kind of keep them organized. Then I have minus a negative 12x cubed, which is really going to be plus 12x cubed. And I'm going to line it up underneath my other x cubed. And then I have minus negative x, which is going to be plus x. I'm going to kind of put it in between the x squared and the 8 since it's not either of those. So now I can combine my like terms. So I have two like terms that are both x to the fourth power. That will give me 6x to the fourth. Then I have a negative and a positive 12x cubed, so those are just going to cancel. And then I just put the rest of my terms in descending order. So positive x squared, positive x, and minus 8. Okay, so now number 2 and 3 are already set up for us in this vertical format. It looks like terms are already stacked on top of each other. The only thing is we have this negative here. So what I would probably do is just go through, and I know this is negative, but then when I distribute the negative or I subtract a negative x squared, that becomes a plus. And then this 17 here will become a negative. So just kind of go through and check those signs. So here, this negative will become negative 2x cubed. This x squared will become a minus. This one will become a plus, and this one will become a minus. And then now I can just easily combine my like terms. So for number 2, 3 minus 5 would be negative 2x cubed. 8 plus 1 is positive 9x squared minus x and minus 22. For number 3, 8 minus 2 would be 6x cubed. Negative 3, and this is now a negative 6, that's negative 9x squared. Minus 2x plus x would be negative x, and then 9 minus 1 is 8. All right, so the addition and subtraction is pretty simple. With addition, I usually just go right horizontally and combine like terms. Subtraction can be beneficial to rewrite it in that vertical format just so you kind of don't mess up your signs and you keep everything together. All right, now multiplying two polynomials you've done before, it's known as FOIL method, right? Really just distributing. So each term of the first polynomial must be multiplied by each term of the next one, okay? So typically I go from left to right, but you could go from right to left. Again, answers must always be in standard form. So the first thing I'm going to do is take my first term. Remember, this is really just reviewing the FOIL, or I call it distributing property. X times 2x is 2x squared. X times negative 1 is negative 1x. And when I go to multiply my next term here, this negative 4, negative 4 times 2 is negative 8x. And I'm actually going to stack that underneath my other one. So now my like terms are already together. And then negative 4 times negative 1 is plus 4. You don't have to do it that way. You could just put them in a long line if you want to. I just write it on the next level because then I can just kind of line up my like terms while I'm multiplying and distributing, and just kind of saves me the trouble of looking for them later. So now I have 2x squared minus 9x plus 4 for my final answer, my final product. Okay, so number 2, I'm simply just distributing this one term to both of these. Now remember your properties of exponents when you're multiplying. So 3x squared times negative 4x is negative 12x cubed because you're really adding those exponents. And then 3x squared times 7 would be positive 21x squared. So you are using all those properties we reviewed last week. Okay, so number 3, we have a binomial in the front here. And we're going to distribute each of those terms from that binomial to everything in this binomial here. So first, I'm going to distribute the x to all 3. So that's going to give me 5x cubed. Remember that property there, adding those exponents. X times 3x is 3x squared, and x times negative 1 will be negative x. Now, when I go to do my second portion here, 2 times 5x squared is 10x squared, and I'm going to line it up underneath my other x squared. Then 2 times 3x is 6x, and 2 times negative 1 is negative 2. Now my like terms are already kind of lined up, so it's just a little bit easier for me to make sure I don't miss anything. 3 and 10 gives me 13x squared. Negative 1 plus 6 is positive 5x. And then I still have my constant there of negative 2 at the end. Theoretically, you could set up your problem like this and think about your old school multiplication. I mean, I'll do it this way just for this one example, but I personally think it's easier to kind of use distributing property. But Yeah, honestly, I'm not even going to write. I'm just going to rewrite this the normal way. I typically like to put the smaller of the two polynomials as my first term and distribute that one to the bigger one. I just think it's a little bit easier. So first we're going to start out with this 5x, and we're going to get 20x cubed plus 5x squared minus 25x. Now I'm going to distribute my second term here, this 2. So 2 times 4 would be 8x to the second plus 2x minus 10. Notice I lined up all my like terms as I did my distributing. So now my final answer is 20x cubed plus 13x squared minus 23x minus 10. All of these notice are in standard form. Most times when you're distributing, if the binomial and the trinomial or any polynomials that you're multiplying are already in standard form, if you do it in this way, your answer will be in standard form as well already. Okay, now numbers 5 and 6, you have 3 different polynomials. In this case, they're all binomials that need to be multiplied together. So it doesn't really matter which 2 you want to pick to multiply. So pick any 2 you want, multiply those together first, and then you're going to take that product and multiply it to the third term, or the one that you haven't used yet. So whether you'd want to start out the first 2 or start out with these 2, it doesn't really matter. So I'm just going to do these 2 first here in the yellow that I highlighted. So that will give me x squared minus 2x minus 3x plus 6. Now the reason I did that is because now this will be my trinomial. So I have x squared minus 5x plus 6. But I now have to multiply my x plus 1 to that. So now that's what I'm going to do. X times x squared is x cubed minus 5x squared plus 6x plus x squared minus 5x and plus 6. So my final answer here is x cubed minus 4x squared plus x plus 6. All right. Now, if you wanted to do the first 2 instead, you can certainly do it this way as well. I personally like keeping my small one out in the front, but it doesn't really matter. So if I were to FOIL these 2, I would get 2x squared plus x minus 8x minus 4. Now I'm going to go by my like terms. So I have 2x squared minus 7x minus 4. Now that product needs to get multiplied to this 3x minus 2. So at this point, I can now do 2x squared times 3x, which would give me 6x cubed. And then I have minus 4x squared. Now I have this middle term here. Negative 7x times 3x would be negative 21x squared. And then plus 14x. And then I also have this negative 4. So that's going to give me negative 12x and positive 8. So because I had 3 terms in my first parenthesis that I was distributing to the second, I have 3 layers or 3 levels of things that need to get combined there. So now finally my answer, 6x cubed minus 25x squared plus 2x plus 8. Okay. So couple more products here to work through. So find the product of the polynomials. Okay, so this one only has 2 polynomials, which is nice. We don't have 3. However, they're each a trinomial, or they each have 3 terms. So just like I showed you in the second one that we just did here, if you have a trinomial and you're distributing the trinomial, you're just going to have 3 things to get distributed, and then that's why I had those like 3 layers with my answers that I had to combine the like terms with. So I'm going to do the same thing here. So I'm going to start out with this x squared, and I'm going to distribute it to all 3 of these terms in the second polynomial. So x squared times x squared is x to the 4th. x squared times 4x would be 4x cubed. And x squared times 2 would be 2x squared. And notice they always come out really nice because they're already in that standard form that we need. So it's just like one less thing you have to kind of worry about. All right, so now I'm going to do the next term here. And negative x times x squared would be negative x cubed. And I'm going to line them up in the next row here. Negative x times 4x would be negative 4x squared. And then negative x times 2 would be negative 2x. And again, if the originals are in standard form, when you do these little like layers here, they'll all be already in order for you. Okay, and then finally, we have the third term, which is this negative 3. So negative 3 times x squared, and that's going to be negative 3x squared. Negative 3 times 4x will be negative 12x. And negative 3 times 2 will be negative 6. And now they're all set up for us. So I only have the 1x to the fourth. 4x cubed minus x cubed will be 3x cubed. Then all my x squares are lined up here. So I have 2 minus 4 minus 3, which will be negative 5x squared. Negative 2 and negative 12 give me negative 14x. And then I have minus 6. Okay, so now if you look at number 8, we see that this is a binomial, but it's cubed. So whenever you're cubing a polynomial it's anything but a monomial. So if it's a monomial, you can kind of distribute that exponent like we did in those properties of exponents problems. But this is not a monomial term, it's a binomial term. So when that happens, you literally have to write it the 3 times and go from there. Okay, now you might remember, you might not, that if you have two terms that are the same or two binomial terms like this, you might remember your perfect square trinomial pattern. And if you do, then you know this is going to be 16x to the second. The last number here is going to be plus 9. And then 4 times 3 is 12. And then if you double that, it's 24x. And then you have the minus sign. It's okay if you don't remember that. You can just do your normal foiling or distributing and combine like terms to get that. Okay, but of course now we still have to distribute this 4x minus 3 to the product we got with those first two. So 4x, distribute this 4x here, to each of these three terms. So 4x times 16x squared is going to be 64x cubed. 4x times the negative 24 is, I believe, negative 96x squared. And then 4x times 9 is going to be 36x. And now we can do the second term here, this negative 3. Negative 3 times 16 is going to be 48, and it's going to be negative 48x squared. Negative 3 times negative 24 is positive 72x, and then negative 3 times 9 is negative 27. And then we would, of course, combine our like terms, getting us 64x cubed minus 144x squared plus 108x minus 27. And of course, that answer is in standard form. Okay, so just to review what we've been doing today, first we went over our addition. So remember, that's when you're basically just combining your like terms, going in order from the highest exponent, working your way down all the way to a constant. So our highest term we have here is this 2x to the third power, and there are no like terms to combine with it, so we're writing it down. Then we're going to look for x squares. We have a minus 4x squared and a minus x squared. So those two terms combined give me a negative 5x squared. Then I'm going to look for my x's. I only have one, so I copy it as it is. And then finally, my two constants get combined to give me that positive 6. Okay, then we went over just basic distributing. Okay, distributing a monomial term to a binomial or trinomial. So 10x squared times x is just 10x cubed. and 10x squared times negative 5 is negative 50x squared. Okay, so now moving down to subtraction. Okay, this is where you have that option if you want to. When I distribute this here, I know this is a minus x cubed, so I'm going to line it up underneath my other x cubed. Then I'm subtracting a negative 4x squared, so I'm going to squeeze in plus 4x squared here. Then I'd be subtracting the 6. And then just make sure you're combining your like terms. So 3x cubed minus x cubed would be 2x cubed. Then I have this plus 4x squared plus 10x, and then my two constants combine to give me a negative 1. All right, then number 4, two binomials being multiplied is just a basic foiling type of problem. 3x times x is 3x squared. 3x times negative 2 is negative 6x. When you go to distribute that second term, it's up to you if you want to kind of stack those answers underneath any like terms you have. So 8 times x is 8x. I'm going to put that underneath my other x. And 8 times negative 2 is negative 16. And now I can easily combine any like terms that I have. And I have my quadratic trinomial answer. All right, so a couple more. So now we have a binomial and a trinomial. So first term of my first polynomial here, and I'm going to distribute that to all three things in my second set of parentheses. So 6x times 2x squared is 12x cubed. 6x times negative 6x is negative 36x squared. And 6x times 1 is just 6x. And notice that they're already in standard form. Then I'm going to do this 2. So 2 times 2x squared is 4x squared. And I'm going to line that up underneath my other x squared. 2 times negative 6 is negative 12x. And 2 times 1 is 2. And then I'm just going to combine my like terms, which are already nicely lined up for me. And there's my final answer, 12x cubed minus 32x squared minus 6x plus 2. Okay, same concept for number 6. Notice this one though, this binomial is still in standard form, but it's missing an x, so it'll look a little different if we're doing this stacking, so just be careful. Okay, so first I have 3x squared times x squared, which gets me 3x to the 4th. Now then I'm doing 3x squared times 4x, right, which gets me 12x cubed. And then 3x squared times 3 is just 9x squared. So far we're all in order. Now when I go to multiply the next term, negative 2 times x squared, my answer is negative 2x squared. So just make sure you're lining it up underneath your other x squared. Then negative 2 times 4x is negative 8x. And negative 2 times 3 is negative 6. So just so happened we only had one thing that was a like term. So now I'm writing down my x to the 4th term, my x cubed. I'm combining my 2x squares to give me 7x squared. And then I finished writing out my terms. So I ended up with a polynomial of 4th degree, or a quartic polynomial. Okay, and then I think these are our last two. Yes, our last two. So again, when we're multiplying 3 different binomials or 3 different polynomials, pick 2. I'm going to pick my second 2 to FOIL first. So 2x squared plus 10x plus 1x plus 5. So that gives me 2x squared plus 11x plus 5. And now I can multiply that x minus 1 to the product that I just got. So when I do that, I will get 2x cubed plus 11x squared plus 5x. Then I'll do the negative 1. So I'll get negative 2x squared, negative 11x, and minus 5. And I'll combine all my like terms to get 2x cubed plus 9x squared minus 6x minus 5, which is a cubic polynomial because the highest degree is a 3. And then our last one, we have two trinomials here getting multiplied. So starting out with that first term, I'm just going to distribute this first term to all three terms in my second polynomial. So that's going to give me 2x to the fourth minus x cubed plus x squared. Then I'm going to go to my next term and distribute that. So x times 2x squared would be 2x cubed. I'm lining it up underneath my other x cubed. X times negative x is negative x squared. Again, lining it up underneath my other x squared. And x times 1 is x. And then finally, I'm going to do my third term here, which is the 4. 4 times 2x squared is 2x squared. 4 times negative x is negative 4x. And 4 times 1 is 4. Now just simply combining those like terms. 2x to the fourth. Then I have a negative 1 and a 2 here, so it's just going to be x cubed. The x squares, these two cancel, so I'm just left with this 2x squared. 1 minus 4 is negative 3x, and then plus 4, so I have this quartic polynomial as my final answer. And that's it. So most of this lesson is really a review. It's just you're adding, subtracting, and multiplying polynomials.